There we go. Got my little shirt on from Cedar Point. I love this too. I used to say this all the time. I might say this year. It's not rocket science, guys. But wait a minute, it is, because a lot of rocket science has just simple math in it. All right. But anyway, talking about like Mr. Stronowski's kid maybe wanting to be a roller coaster engineer because he loves roller coasters. Before I continue, let me put something off to the side. These random thoughts by Mr. Samuelus. What inequality belongs between these two numbers? 3, 2, 1, go. Less than, right? That's all I was asking. Isn't that true? Correct? Right? If I randomly decided, you know what, I'm going to divide both sides of this inequality by a -1, or multiply both sides by a -1. So remember, I filled in that inequality after the fact. Now this turns into 6, and this turns into -5. What's true now? What inequality belongs between here? 3, 2, 1, go. Greater than. So what just happened here? The relationship what? Starts with an F, FL, FLI. Flipped. Went from less than to greater than just by this concept. Guess what a variable is? It starts with an N and ends with umber. What is a variable? It's a number. It's just a number in disguise. We don't know what it is. That's why it's called a variable. It changes every day, every time we deal with X. So the very next thing that I have to do to solve for X, again, I like to show you where things come from and not just tell you a rule. Because this is a number, and I've divided by a negative, the relationship of the numbers flip. And that's true because of what I showed you over here. There's the y, if you ever wondered why. Okay, anyway, now it's got to be a rule. Anytime I divide by a negative in an inequality, the inequality flips. Good enough. Notice what this said here. Put your answer, if I cut that off too quick, in interval notation. So I know you know how to do this Mickey Mouse question. Maybe didn't remember about the flipping. But also it's about getting this in interval notation, which it might be helpful to think about the graph of this. First of all, we should remember that we have a filled in dot because it's an equal to. And then which way do I shade, to the right or to the left? 3, 2, 1, go. Right. These are numbers that are greater than. Once I think about that, then interval notation is not a problem. What often happens is when we see this inequality, we don't do this right? And we go the other direction. I stopped. What should I have on one? A bracket or a parenthesis? 3, 2, 1, go. Bracket. Listen to your friends. All right, so we'll leave you alone individually. At least get those group responses going. Why a bracket? Because 1 is equal to 1. The equal includes. Okay, so knowing how to do interval notation. Next thing, input, say it. So here's what this asks, and I'm not going to do this one because of time. Is the value for x a solution to the given inequality? So if I ask you that, it's an input, say it. Output question. The reason I do this one, we've talked about this before. We've talked about PEMDAS. We've talked about how do I evaluate this correctly. And I'm going to write PEMDAS up above. It's amazing how many times this is violated, the idea of PEMDAS and not doing the order. So exponents are first. What I'm making a point of is you can't multiply first. That means you can't take negative and a negative, it becomes a positive. You must square first. So this is 9, and then attach that negative and now do multiply. That's really -1 times 9. So it is multiply of PEMDAS. I'm actually allowed to multiply here. It's not really out of order. I can kind of go to different parts and accomplish different things there. So I can multiply before I add. All right, and then -9 plus 15 is 6. 6 minus 4 is 2. True or false, everyone? This is false. So -3, not a solution. That's what a solution means. It makes the equation true, and that's the only reason I wanted to show this example. And also do a PEMDAS thing to make sure you can do your order of operations correctly. Okay, and now we're going to talk about input-output, but we're going to analyze graphically. So first thing I want you to write is this picture. And I'll prove that this picture does have the x-intercepts that it does. So down in this corner, maybe below it even, it's x squared minus 3x minus 4. We're analyzing that picture. And by the way, as you type this or write this down, I'll go ahead and factor. What multiplies to negative 4 and adds to negative 3? Negative 4 and 1. Good FOILers, good factors. You just check that real quick, and this is correct. Well, therefore, the x-intercept is at negative 4, wrong, 4, and negative 1. And that's why you see what you see here. And of course, it's a 1x squared, so it goes up, so we'll do a quick sketch of that. You can do negative b over 2a to get the vertex and find what that is specifically. We don't really need to. Hopefully I can get to the question that I didn't have with the other period. All right, now, here's the questions off to the right. Well, identify the zeros. I think last hour I didn't even write them because we already had them. The zeros are already 4 and negative 1. All right, and I factored that to prove that. Okay, now I'm going to use color coding. The x-axis is divided into 3 sections. Using interval notation, identify those 3 sections. Here's what the x-axis does. It actually cuts this graph into above and below pieces. And then I'm going to color the aboves the same color. Those are the 3 sections. Okay, and that's what we really need to focus on. And if you can get this section is infinitely easy. It really is. So, but remember what we said, using interval notation, what are these 3 sections? You need to do input-output analysis. The output is the y, the input is the x. They're asking for the x's in those intervals. So that interval that I colored right there is from negative infinity to negative 1 for x. And I'm going to use parentheses right now. I'll tell you when you use brackets when you actually solve the inequality. All right, so that's one section. Those inputs create positive outputs. That's the graph that is above right here that I'm identifying. And then this blue section, which I'll pre-highlight here, that is these inputs. When I input those x values, I get these blue outputs, which are negative outputs. That's where we really need to focus on. So that's from negative 1 to 4, the 2 zeros. And then pre-highlighting the last section, obviously, I think you should know that this is 4 to infinity. I'm ignoring the actual zeros like that are right on the x-axis. That's why I'm using parentheses for right now, just to identify those 3 parts. So now, and I'm going to erase these little shaded or whatever you call it, squigglies there. Now it's time to solve this inequality. First things first, kind of grab the highlighter, but what kind of numbers are greater than 0? Positive or negative? 3, 2, 1, go. Positive. That's such an easy question. I actually grabbed the correct highlighter. I grabbed yellow because it's the yellow outputs that are positive right here. So this is why this is going to be the simple solution. When I plug in negative 3, I don't have to plug in negative 3 anymore. The graph tells me when I plug in negative 3, I get a positive number as an output. So when I plug in negative 3, let's go to this, into this inequality right here, I get a positive number. Is a positive number greater than 0, true or false? True. So that's why it's a solution. As a Federact, all of these x values plug in and get positive outputs. So all of these x's and also all of these x's. When I plug it in, I get a positive output, which is greater than 0. So these solutions that solve this inequality are the yellow solutions, the ones that I have up there. I'm stopping. Sorry, that's a 4, not a negative 4. What should I put on 4 and negative 1? Parentheses or brackets? Ooh. What happens when I plug in -1? What does this turn into? Starts with a Z because it's called this. 3, 2, 1, go. 0 is 0. What are you looking at? Looks like is there a bird back there or something? You're looking around like, all right? -1, when I plug it in, this gets 0. Is 0 greater than 0? True or false? False. So what do I have on -1? A bracket or parenthesis? Parenthesis. And then you put a U in between. Next one. What kind of numbers are less than or equal to 0? Positive or negative? 3, 2, 1, go. Negative. That's why I'm going to color that in blue right there. So what are the inputs that make this happen? Well, it's all of these. For instance, when I plug in 2, and I can plug in 2, I'll do it real quick. It's not a big deal. 2 minus 4 is -2. 2 plus 1 is 3. 3 times -2 is -6. Is -6 less than 0? True or false? True. All right, so that's what this means. So the solutions for this are from -1 to 4. What do I put on -1 and 4? Brackets or parentheses? 3, 2, 1, go. This is brackets. Because what happens when I plug in -1? I get what? It starts with a Z. 0 is less than or equal to 0. True. So that's why we have to include those for the solutions. And really, I could be done. But then again, I'll show you some more examples of people that are still struggling to factor. All right? And then there are some special cases, but we'll do 5 examples, and I might just have to verbalize the special cases because it can be a little bit tough. Now, I'm changing 3 and 4. I'm sorry, 4 and 5. 4 and 5 kind of changing to graph analysis. Input, say it. The graph is an input-output. It's telling you the outputs. So I don't really have to plug in numbers. I checked 2 just to verify. In that last one, I literally did plug it in. You don't need to. So you do get the roots to divide the number line into regions, but we're just going to graph. We're going to graph the corresponding parabola that fits those zeros. And then we're not going to test each region. We're just going to look at the graph and look at the outputs that I want, above or below, depending on the inequality. That takes care of number 5. It makes our life a lot easier. Right? And then most important, write the solution using interval notation. That's why I think these next 2 days are pretty simple. We're just stretching out one extra idea. So you got to know how to factor. So I don't know how to find the x-intercepts after that, and then your analysis. That's it. That's the only difference today. We add these little components in our brain, and we're able to deal with it. Let me check what time we get out of key. Special little day, 9:08. Really? Yeah. 15 plus 8. 23, I think. Oh, went to the White Sox game yesterday. Good game. Anyone a Sox fan? Raise your hand. Only a couple? Oh, hope you're excited. What's today, Thursday? I think that the feeling might be that they play a week from today for playoffs. That might be, I don't know if they have a schedule yet. So, can't wait for that. Super excited. All right, you done writing these little steps? See a couple people writing, they do like those notes. Okay, it is imperative that you do get the inequality equal to 0. You kind of ignore the inequality until the end. The graphical analysis is when you look back at the inequality. Factor the quadratic. What if it's not factorable? What if it's not factorable? What do we got to do? It's a song. Quadratic Formula. Okay? Give them a little song on the calendar. You might be stuck with this. Example number 5, we actually do that. And then that's why last hour I just verbalized some special cases. And hopefully after doing 5 examples, you can think about the special cases as well. Maybe as you walk out, I think I have some special cases lined up here. Okay, so number 1, this is not compared to 0. So I'll give you a second to write the original 1. And then the very next thing you have to do is subtract x. subtract 2, and compare this to 0 so I can do my graphical analysis. But then the other thing is, I'm not even going to bother you today. If you don't know how to factor this, you're doomed. What multiplies to negative 2 and adds to negative 1? What are the two numbers? 3, 2, 1, go. Negative 2 and 1. It can't be any easier than that. Just a real basic understanding negatives and positives. Good FOILers, good factors. I'm not annoying by saying that. Well, maybe I am. But the point is you check. Some people write answers that are not sensical, and I'm just going to get you with the red pen. Because at this point, it's unacceptable to write an answer that doesn't FOIL to be the question. It is completely and totally. All right, so we got to make sure we do that as honors students. At this point, we leave the inequality. We think about the graph of this. And we know that this is 2, 0, and we know that this is negative 1, 0. Those are the x-intercepts. By the way, which way does this graph, up or down? 3, 2, 1, go. Up. So therefore, I can go ahead and make that sketch. This is 100% true because of those factors. Those are the x-intercepts, and that would be the graph that goes through those x-intercepts. What do I want? Do I want above or below? 3, 2, 1, go. Below. Those are numbers that are less than 0. So I want these outputs. So the answer is these inputs. Got it? Input, output, x, comma, y. These are the negative y's. These are the negative outputs. And by golly, it's simple. One of them is the y-intercept. What is the y-intercept? 0, comma, negative 2. So when I plug in 0, I get negative 2. Is negative 2 less than 0? True or false? True. That's why I did that second example. What does it mean to solve an inequality? You got to make the inequality true. The blue ones make it true. All right? The blue outputs. So I need to name the x's, which is from negative 1 to 2. I already put parentheses there. I'm sorry. Why parentheses? What's missing? What's missing? Starts with an E. Equal. Now I know this looks like a coordinate. It's not. These are the x's that can be plugged in. Don't get that out of your head, because tomorrow we're going to solve systems. The solution to systems are coordinates, all right? And that's where our math notation. That's where I kind of don't like interval notation. Students might get that all jumbled up in their brain. Sometimes those do look like coordinates, and they're not. Give me a second to write this. You always got to compare it to 0. So therefore, I have to add 7. 13 plus 7 is 20. Listen to your friends. What multiplies to 20 and adds to 9? 3, 2, 1, go. 5 and 4, 4 and 5. Doesn't matter what the order is. Good FOILers, good factors. At this point, we leave the inequality. We think about the graph. Okay, kind of weird. Not kind of weird, I guess, but 1, 2, 3, negative 4, negative 5. Yet again, which way would this parabola graph, up or down? 3, 2, 1, go. Up. So those are the squeezed x-intercepts. This would go like this. A little bit down and then a little bit up. What do I want, above or below? 3, 2, 1, go. Above. Input, output. These are the outputs that solve the inequality. These are the inputs that I want to get to get those outputs. Okay, so looking at that, this can't be any easier. All right, but what do I need on negative 5? A bracket or a parenthesis? 3, 2, 1, go. Bracket. The reason is it's right here. When I plug in negative 5, I get 0 times negative 1, actually, but that's still 0. Is 0 greater than or equal to 0? Equal to. So it is true. It is part of the solution set. Union that with negative 4 to infinity with a bracket, same reasoning. Negative 4 solves because there's an equal. Can't be any easier. So we're doing the factoring. You just got to do a number line analysis after that using graphs as an aid. Oh, geez Louise. Let's increase a little bit the difficulty level of the factoring. But still, for the love of dog, do not do a four-step factoring on this. You are still in the, not challenging your brain even in the slightest. Good FOILers, good factors. What does this have to be? What do those two positions have to be in order to equal 2x squared? 3, 2, 1, go. 1x and what? 2x. 2x and 1x, 1x and 2x. I don't care who you put where. It doesn't matter. Then look at last. You only have 2. That's only 2 times 1. But what does it have to be when you have a negative middle term? Both 2 and 1 have to be what? Negative. Now, I'm going to tell you why this can't be the case. It cannot possibly be here. That cannot possibly be. Because what does this factor have? It starts with a G. GC. Hurry up. GCF. Is there a GCF in the original? Yes or no? No, so then that cannot happen. And that's something you probably should know. So actually, I'm giving you a little bit more solving skills why unfoiling sometimes really gets easy. So if you're doing a four-step process here, you again are rejecting, getting your brain to figure out how to factor and unfoil. So frustrating. Students that just want to have a robotic method and just memorize that method and not really know what's going on behind the scenes. It's got to end. All right. Okay, so we're done with analyzing that inequality right now. Well, actually, that's not true, but we're done with the inequality of sorts. We're going to solve this graphically. All right, so 2, 0, hopefully that's not a big deal. Add 1, divide by 2, a half. Yet again, which way does this parabola go, up or down? Up. So this is how the parabola would fit in this. So I haven't had a question with the leading coefficient that's negative. It can happen. A lot of times when I have a leading coefficient that's negative, I'll divide both sides by a negative. Be careful with an inequality, though. What happens to that if you choose that? It what? Flips. But that's totally legal if you do that. You just got to flip the inequality then. So I know if I had a negative leading coefficient, I would definitely divide by a negative. I would. Makes my factoring easy. But that didn't happen in this question, just speaking out loud. I'll stick with the color coding of the notes. What am I looking for, above or below? 3, 2, 1. Below. And it's this little thing right here. So these are the inputs that create those negative outputs. What do I put on 1/2 and 2? Brackets or parentheses? 3, 2, 1, go. Everyone should be saying brackets. If you're not saying brackets at this point, I got a problem with that. All right, there's an equal to. So what happens when I plug in a half? I get 0. 0 is less than or equal to 0. True. That's the point. Yet again, repeating, because I get people that pick up things at different times. Okay, then this one, the point of this one is to have an annoying question where you actually have to simplify stuff. Here's another. I'm going to get you, and I'm going to be real ruthless on you if you're still doing this. If you do this, I am instantly. This is like you're gonna lose 3/4 of your points. I cannot abide this happening anymore. All right, just squaring x and squaring 3. It's a word that starts with an F. What you're supposed to do with that? Don't say factor, robots. What is it actually? FOIL. Okay. So we got to make this x plus 3 times x plus 3 in our mind. I'm still getting people do this. It's happening in CAT as well. And I'm ruthless with that. It's just an unacceptable mistake at this point, especially when I've covered this and told you. I've acted like this every single time. Stop doing this. And I don't know, I still got people doing it. So skills. And please be good foilers. This is 3x and 3x. Should be able to hold that in our head and add them. And then 3 times 3 is 9. And then, look at this. When I subtract to get this equal to 0, the x's completely go away. Well, listen to what I say here. You could do two things at this point. Luckily, this is factorable. What if it wasn't, though? Then you do have a choice to add 81 to both sides. ignore the inequality for a second. Make it an equation in your mind, and then square root both sides. What's the square root of 81, by the way? But I square rooted both sides, so what should I put in front of it? Plus minus. So if you did that, and say it wasn't a perfect square, say it was like square root of 80, like say this was 80 instead of 81, you'd square root both sides, put a plus minus, but then you'd break down the radical. Square root of 80, I picked that on randomly. Oh, that's 16 times 5. What's the square root of 16? 4. So it'd just be plus minus 4 root 5. Those are the x-intercepts, and then you'd still do a graphical analysis. By the way, which way does this go, up or down? Up. But it is factorable, so I'll go the factoring route to keep this the same. I had to 5 times before that 9 wrote. Love my pen. Just drives me crazy. All right, and then we go to this where this is 9, I guess, first, but then also negative 9. By the way, what's the y-intercept? It's nuts. What's the y-intercept? 0, comma, negative 81, way down there. All right, so that's also proof that this goes up. What am I looking for, above or below? 3, 2, 1, go! Above. I forgot what color I did above. I think it was yellow, but it doesn't have to match my original notes. So it's these answers, those inputs. So it's negative infinity up to negative 9, and then I've asked you this a million times. You should know that it's a bracket, and then 9 to infinity. Okay, so I kind of verbalized what if it wasn't a factorable situation. You're allowed to add 81 and square root both sides. You just got to get a plus minus. You got to get those 2 answers. And then you could still go back to the original and think about the graph after you solve for that. All right, and then I think I do have time to do 2 more. Sorry, but I think this is important that you see all these possibilities, all these mathematical, solving skills and all that other stuff. This one is the one I was talking about before. Or you would have tried to unfoil and nothing works. And then this is a clue if you wanted to see, is it factorable? But I'm not going to do the 4-step method. But I just want to know, is it factorable? Then these numbers should exist, and they don't. Nothing multiplies a negative 6, and then those same 2 numbers add to be 3. So if it's not factorable, what must I do? It's a song, everybody. The quadratic formula. The opposite of b plus or minus the square root of b squared minus 4ac. Thank you, pen. All over to a... Oh, so much fun. Oh, stupid pen. Sorry. Take a deep breath. Okay, the thing you should recognize here is I have a minus, and one of these numbers is negative. What's a negative negative, everybody? Positive. And I'll color code it just so you see that I made that change. Should be identified. If both A and C were negative and you have a minus, that's a negative negative negative, which is a negative. Okay, so just make sure you keep track of those. And then just doing this last hour, I ended up with negative 3 plus or minus a root 33 all over 4. Now, I did do this on our calculator. Watch my math here, how I did it. I did negative 3 plus root 33, and then I pressed enter. I didn't want to search for parentheses to get the numerator. I didn't want to search for the fraction button. This is fast. Do the numerator, press enter, then divide by 4, press enter. 0.69 around. And then do the numerator, the minus, enter, and then divide by 4. Negative 2.19. Very good skill there. 0.69, negative 0.29. So 0.69 and negative 2.19, I believe, right? Is that what it was? Right? Okay. That's what x equals. Well, now we can do the same analysis, and all we have is decimal x-intercepts. Couldn't get that word out of my mouth. By the way, which way does this parabola go yet again? 3, 2, 1, go. Up. All right, everything seems to be going up. All right, so here's 1. So there's 0.69. Here's negative 2.19, somewhere approximately right there. All right, and then it goes up, and then yet again, what am I looking for? Let's go back up to the original. Above or below? 3, 2, 1, go. Above. All right. Huh? I thought someone said below. It's definitely above. So these are the x's that I want. Blah, 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 blah. Is everyone okay? I heard someone laugh. Is there a joke out there that I missed? I like jokes. Negative infinity. Be careful, to negative 2.19. I think last hour I accidentally put 0.69 first. That's wrong. By the way, open or close? 3, 2, 1. Open. Sorry, I meant parenthesis or bracket. Same thing. Parentheses open. Union that with 0.69, comma, infinity. What if they ask for exact? Then what would be in this place is this was the negative 3 minus root 33 over 4. This is the negative 3 plus root 33 over 4. And we can insert those in those positions, and then that would be the exact answer. Okay, I guess I'm just going to cover this in the last 5 minutes verbally. Imagine if I got I numbers here. So imagine I had a square root of a negative. What does that mean about x-intercepts? Are there any? 3, 2, 1, go. No. So if I got an I number through the quadratic formula, which I think this kind of happens with one of these two. So say I'm getting x and I get an I number. And it came from like 2x squared plus ... And then let's say it was greater than or equal to 0. I'm just imagining that this happens. Okay, just bear with me. So which way does this go, up or down, first of all? Up. And I get an I number for zeros. You know what that means for the graph? It means the graph is like this. Because it's going up and it never hits the x-axis. Am I wrong? Yes or no? No, I'm not. All right, that's actually the correct answer. So here's my question. What inputs solve that inequality now? And the answer is all of them, right? Isn't this all above? What color did I use for above? Yellow? This is all above. Doesn't that solve greater than or equal to 0, correct? So what are my inputs that make that happen? Every single stinking one of them. This would be negative infinity to infinity for that answer. Yes? No? Does that make sense? But what if it was less than, and I had 2x squared plus a bunch of stuff, and then it said less than 0, and I get x equals an I number. That means, yet again, we are above all the way through because it never crosses the x-axis. But then what solves this? Nothing. All right, because you're above there, so therefore this would be no solution. Those are the special cases that can happen. That's what you have to analyze with an I number solution. That has to tell you that you know where the graph is, and therefore, you know what inputs solve the inequality. Be careful on that one. Of course, if you have a negative leading coefficient in an I number, then the graph is all below the x-axis because it never crosses the x-axis. So hopefully that is doable for you there, those special cases without doing one for sure.